Sometimes we want a way to write very large numbers like the number that I have in blue, or very small numbers like the number that I have in red in easier ways. For example, the number in blue, we could, even that isn't really a large number compared to how big numbers can be. For example, distances to the nearest star. Those numbers can be very large, and sometimes those numbers are so large that it almost takes more time to write them than to what we want to use them for. Or, for example, in the red, maybe the how small a microbe is. Those numbers can be very small, and we want to write these numbers in convenient ways, or ways that are less time consuming. And this is what we call scientific notation. Scientific notation is a way to write very large numbers or very small numbers in a short and less time consuming way. Let's take a look at example 1, and let's see what scientific notation really is. Scientific notation, before we get to the four numbers that I have written down here, scientific notation is simply a number between 1 and 10, and this is something that you'll want to make note of. So it's a number between 1 and 10 multiplied by a power of 10. So in other words, 10 to some exponent. And let me write that question mark a little better or neater way. So scientific notation is a number between 1 and 10 multiplied by a power of 10. So 10 to some exponent. Right now, keeping that in mind here, let's take a look at the first number. And really, the first number isn't a really big number. It's 47,800. Now, to write this number in scientific notation, locate the decimal point. So right now, in any whole number, the decimal point's always to the far right. And we want to move that decimal point such that we get a number between 1 and 10. And the only place I can place that decimal point is between the 4 and the 7. That's the only place I could put it so that I have a number between 1 and 10. If I put it between the 7 and the 8, that'd be 47.800. It has to go between the 4 and the 7. So if I place that decimal point between the 4 and the 7, I get 4.7800. Now, since I have a decimal point, or since I have a decimal, I can leave those zeros off at the end. So 4.78 times, so now I have my number between 1 and 10, and it's times 10 to some exponent. Well, how many times did I move that decimal point from the right? 1, 2, 3, 4 times. So in scientific notation, this number is 4.78 times 10 to the fourth. And again, I was able to leave the zeros off at the end, and instead of writing 4.7800, well, 4.7800 is the same thing as 4.78. And this would be a number in scientific notation. Now let's take a look at the next number, 41,650,000. Now where is the decimal point? Well, it's right there. In a whole number, it's always at the far right. Now I want to move it right in between the 4 and the 1 to get a number between a 1 and 10. So I'm going to end up with 4.165 and then 0000, but I can leave those off because they have no value at the end of this decimal. So I have 4.165, which is between 1 and 10, times 10 to what power? Now how many times do I have to move the decimal point? I moved it 1, 2, 3, 4, 5, 6, and 7 times. So it's 4.165 times 10 to the 7th. Now before we go to these next two very small numbers, let's go back to the two that we just did. What would you do if you had 4.78 times 10 to the fourth and you were asked to write what the original number was, or in other words what we call standard form? Well, the decimal point was moved 4 places to get to right there, right? So which way would you move the decimal point to get back to its original number? Well, since you were able to see what the original number was, we'd see that we'd have to move the decimal point back to the right 4 places. In this number, we'd move the decimal point back to the right 7 places. So if we have a positive exponent, what's this mean? It means the original number was bigger than 1, right? Because here I had 47,800, I had 41,650,000. Now, keeping that in mind, let's take a look at the next example. 0.000013. Now here I have a very small number, don't I? Or a number less than 1. Notice the numbers above were numbers greater than 1, and we got positive exponents. Now if I have a number less than 1, like this one is in the red, okay, I want to move the decimal point to a place where the number is between 1 and 10, and it'd have to go right there. So my answer would be 1.3 times 10 to the, now since I have a number less than 1, or in other words, since the decimal point is being moved from the left, so the decimal was moved from the left to get to over here to the 1.3. So let's see, on a number line, what's to the left? And usually you think of negative numbers, so this would be a negative value. So it was moved how many times now to get to the 1.3? Well, it was moved 1, 2, 3, 4, 5 times. So in scientific notation, and I'll make my 5 a little clearer there, I would have 1.3 times 10 to the negative 5. Now let's do the next one. I need to move the decimal point from here to between the 3 and the 2 to get a number between 1 and 10. So it would become 3.21 times 10 to the what? Well, I moved it 1, 2, 3, 4 times, so a negative 4. And again, kind of like the numbers up above, I don't have to have those zeros. I can leave those zeros off in front. I don't need to write 0.21. Those zeros at the beginning have no meaning. So there's a couple of things that you want to take note of here. If the exponent is positive, that means the original number was greater than 1, or in other words, the decimal point came from the right. So here the decimal point came from here and it was moved to the left, right? It came from the right. Now if the exponent's negative, it means the original number was less than 1. It was a very small number, and the decimal point came from the left. Let's take a look at example 2. Now here we want to write the numbers in standard form. So what was the original number? Now remember what I just noted before. If the exponent's positive, as it is here and here, that means the original number is greater than 1. So if I have 3.2, and I'm going to leave the decimal point off, I need to move the decimal point back to the right to get a number bigger than 1. So the decimal point was right here. I'm going to move it back to the right 4 places. 1, 2, 3, 4. And I end up with 32,000. So I'm going to erase this, place my comma in there, and my original number then is 32,000. Now how about the 4.3 times 10 to the 6? We'll move it back to the right 6 places. So I add some zeros in the direction I'm moving the decimal point, and I'm going to move the decimal 6 places. So 1, 2, 3, 4, 5, 6. And there I was just able to, you just got to use a little trial and error in how many zeros you need to add. Now I'm going to place my commas in, and my original number is 4,300,000. Now in the last two, the exponents are negative, so that means I'm going to move them to the left. They came from the left. So the 1.2, I'll leave my decimal point out. I'm going to add zeros to the left now. So the decimal point was here. I'm going to move it 1, 2, 3 places. So I have a 0.0012. And that was the original number. Remember, negative exponent means the original number was less than 1. Now, how about the 2.1? So if I take the 2.1 and I'm going to add some zeros to the left, since it's a negative exponent, I'm going to move the decimal point to the left. So the decimal was here between the 2 and the 1. I'm going to move it left 4 places. 1, 2, 3, 4. It ends up right there. I place a 0 in front of it. and I'll erase this, and my original number then was 0.00000021. Okay? So positive exponent, original number was greater than 1, decimal was moved from the right. Negative exponent means the original number was less than 1, decimal was moved from the left. All right, keeping this in mind, let's look at our last example. Write in scientific notation. Now, as you look at these two, you might say, hey, wait a minute, these are in scientific notation. But there's one thing that on why they're not in scientific notation. Notice that the number isn't between 1 and 10. All right? So that's why they're not in scientific notation. They're close. Now, look at the first one, negative exponent. Where did the decimal point come from? Now, first of all, where is the decimal point? It's right there. Now, since I have a negative 11, the decimal point was moved 11 places to get to right there. So I need to move it back 1, 2, 3, 4 to get a 4.99. Now we got to figure out how we adjust the exponent now. Now since the decimal was moved 11 places from the left to get to right there, I'm going to move it back 1, 2, 3, 4. So it's not moving as much, right? I move it back 4. So if you're at a negative 11 on the number line and you move it and you're not moving it 11 places, well, it's a negative 7 then. All right? So let me just kind of clear that up a little bit. Instead of moving it 11 to get to right there, we're only moving it 7 to get to right there. Okay? So my number in scientific notation now would be 4.99 times 10 to the negative 7. How about the second one? It's easy to locate the decimal point. Okay, it's right there, right? Now, where did it come from? Well, the exponent is positive, so it came from the right 3 places. So it came from this direction, and it was moved 3 places to get to right there. Now we're going to move it back 1, 2, 3. If we moved it back 3, now it's right here, right? Now, that's a 0.499, which is a number less than 1. Now we need to change that to a scientific notation. So it becomes 4.99 times. Now, I moved it 3 places to get to 0, right? If it was moved 3 places to get to here, if you move it back 3 places, okay, I'm at 0. It wasn't moved. So now I have 0.499. Now I need to move it. I need to take that number less than 1 and change it back to a number between 1 and 10. So it would be 4.99 times 10 to the negative 1. So this is a brief introduction of scientific notation. And remember, scientific notation is just a easier, less time consuming way to write very, very large numbers or very, very small numbers.